Just start recording immediately. So you're welcome to our class this evening. We are going to begin immediately, but before I go on, I'm going to just talk about few things, just reflect over what we shared yesterday in our class. And yesterday we talked about one or two stuff. We talked about arithmetical operators, and you can remember very well that in discussing the arithmetical operators, we are able to bring out a lot of operators. And we talked about the addition operator, the division operator, the multiplication operators, and a whole lot of other operators as well. We were able to discuss yesterday. Then also that yesterday we also talked about the Python list. We took our time to discuss a lot about the Python lists, and that would be like the Python list part 2. And on that we're able to access items in our Python list, and we're able to also loop through our Python list. That was what we did yesterday. So this evening we're going to be looking at a few other topics as well. We're going to be advancing a little bit. We're going to look at the Python set this evening. We're going to look at the Python set tonight. Okay, the Python sets. And I want to believe you can see my screen. Yes, you can see my screen. So tonight I'm going to be discussing, the first thing I'm going to look at is the Python sets. Okay, the Python sets. So the word set is not actually a popular, it's not an uncommon word, it's a very popular word. And the first application or our first experience with sets should be in the elementary mathematics, where we talked about the set theory and the rest of them. So now we're going to look at set in the as it applies to Python. Okay. Now, just like we have the list, just like we have the tuple and other data types, the Python set is one of the data types we are also going to consider this evening. And the thing about the Python set is that, like we said in the Python list is actually a list of items enclosed in a square bracket. And I say the Python tuples are actually also a list of items enclosed in a parenthesis, but not in a square bracket. But in the case of the Python sets, we're going to look at a list of items enclosed in a curly bracket. Okay, list of items. For instance, we say z equals to, then you have your curly brackets. Then you have these items enclosed in your curly brackets. Okay, this is actually a Python set, a very good example of a Python set. Now, in the Python set, we can perform, the various operations we also do in our normal set theory. If you can remember very well, in our Python sets, we can actually carry out an operation called the union. And also we have an operation we call the intersection of a set. So here also we can apply that. We can have two sets, for instance, set Z and set Y. Now let's say set Y has a collection of these items. You have 5. Okay, so alright, so we have these two sets, and now you should be able to see a set and clearly tell that this is actually a set because it's enclosed in a curly bracket. Now the very simple operation we can perform here is the union of the set. We can look for the union of the set, and we know that the union of the sets is actually a set of all the items in these two brackets, a combination of all the items, but there is no repetition. And it simply means that if there is double appearance of any of the items in the curly brackets, it will not be repeated twice. Okay, so to do that, we can just say maybe to find the union, I can say UN is equals to Z union Y. I can say Z dot union, in bracket I'm going to say Y. So this should actually give me the union of these two sets. I'll just go ahead and print my UN. So I'm printing my UN. Okay, so Z union Y. Okay. Let me go with intersection. My Z intersection Y is supposed to give me this. Okay, let me figure out what the issue is, because I should actually have that. Okay, so I have UN equals to Z. Z is the, okay, the challenge I'm having here is that my Z here is in capital. Okay, my other Z is in capital, but my Z here is small z, so I need to correct that, because we said our Python is case sensitive, so I have to go back and correct this. So that's the challenge I'm having. So now I think I have this. So I'm having Z dot intersection Y. So I'll go ahead and print that. That should give us a correct value. But what I'm doing here, I'm doing intersection. Okay, I'm doing intersection. And intersection means that it's looking for a number that is common between the two sets. A number that is common between these two sets. Initially we had a capital Z here, that was why we're having the error, and we're not having any outcome. So in writing our programs, we have to be very, very careful how we use characters or use our identifiers. If there's any difference between what we are using as identifiers, we might not have any reasonable outcome. Okay, so now Z intersection Y is 5. So if you go through the list, you see that the only intersecting number in the two sets is 5, because here we have 5 here and we also have 5 here. So we can also perform the other operation, the set operation, which we call union. We can also say, we can say you can say, okay, union, you can say UN, that's supposed to be UN equals to, we can say Z dot union, okay, union Y, Z dot union Y. I'm trying to see the union, and I said the union is actually a collection of all the items in both sets, a collection of all the items. So if I print this, I should expect a collection of all the items, but there will be no repetition of item. So that's the difference between the union and intersection. Okay, so I'm having this also, UN is equal to Z. There was an omission of N, so I'll just go ahead and do that. So here I'm having a collection of all the items in both sets, and it is organized in this case. And you can see we have one here and we have one. It's going from the least to the highest. Okay, so these are actually the two basic operations we can carry out using the Python sets. So apart from this, you can use just, we have the intersection, we have the union. So there are so many applications of this as we keep writing our codes. So just bear in mind how this was used. And basically, we start from us identifying our sets, and we said our set is actually an inclusion of numbers in a curly bracket. And we have named our set. I use Z here, but it is not a must for you to use Z. You can just use anything. You can just use the name of, you can just say set of shoes, you can just say shoes. Okay, it could be shoes, and then in this case, you can just name it anything. You can just say whatever you want to call it. You can just say class, for instance. Okay, but whatsoever name, but class here we cannot use because class is a keyword, but you can just leave it as CLAS. Okay, but whatever name you choose, okay, it's just okay. as long as you're not using a keyword to name your identifiers. Yeah, so there's no strict rule in respect to you choosing identifiers, but the only thing is that you must not use a keyword. You must not choose identifiers with a keyword. It's very important to do that, and you understand that it's very, very important. So that is just the basic thing about the set. Now from here we're going to look at something else. I want us to look at something this evening, and that is what we call the Python type conversion. I want us to look at the Python type conversion, and throughout the course of our lectures we've been looking at types, classes of items. Now we need to know how we can convert them from one type to another. It is possible for you to convert your items from one class to another. So Python types conversion. Okay, so now the first we're going to look at there is the conversion of integer to floats. Okay, the conversion of integer to floats. So the conversion of integer to float, that's the first thing we're going to look at. Now for instance, I can say a is equals to 5. Okay, and I say b is equals to 6.8. Calling your mind back to our previous classes, I explained something about float and integer, and I said the integer is a whole number. So all whole numbers are classified under integer. And then also we talked about the floating point numbers. And I say floating point numbers are numbers that contain decimal parts. Okay, the floating point number has the whole number and the decimal part of it. So the 6.8 we're seeing there is actually a floating point number. So the type of the type is actually different. In this case, if we want to find the type of this number, it's going to tell us that this is an integer. Then if you want to find the type of this, it's going to tell you that this is a float, because it contains a decimal part. Now, in doing your calculation, you have to do some conversions. Some of the conversions are actually implicit conversion because it is done automatically. Like if you want to add a and b, it's going to be an implicit conversion where you're saying, you can say, okay, sum, okay, equals to a plus b. Okay, a plus b. Now if I decide to print my sum, let's see what the outcome will be. So the outcome is going to be 11.8. It's going to be 11.8, and this is actually an automatic conversion because 11.8 is a floating point number. In that case, this 5 have been automatically converted to a floating point. Okay, so that is what is happening there. So you're seeing that we're having 11.8. So this is an implicit conversion system where automatically the Python values are converted, okay, to be able to get the actual outcome we're looking for. Okay, so we can convert from integer to floats, and also we can also convert into complex numbers. In looking at the number system the last time, we talked about 3 basic number types. We talked about the floats, we talked about the integers, we talked about the complex numbers. And I explained to us that the complex numbers are numbers with 2 parts. Okay, it has a whole number part, it has an imaginary part. And the complex number type is something like this. I say complex equals to, for instance, we have 5 plus let's say 3g, for instance. Okay, 5 equals to 3g. So the 5 you're seeing there is the whole number part. Okay, and the 3g you're seeing there is the imaginary part of the complex number. Okay, so now we can also have an automatic conversion of this. For instance, if I may have an integer here. Let me just call it number equals to, I can just give it, okay, 8. I'm having integer 8. Okay, so I would like to add this integer number. I want to add it up together with the complex number I'm having there. Let me see what the outcome will be. So I'm going to say add equals to num plus complex. Num plus complex. So I'm adding the integer to the complex. So let me see what happened. So I'm printing my add to print my add and see the outcome. I'll just go ahead to print my add. Okay, so I have two print statements here, so that's why I'm having two outputs as well. So the first print statement is for the first output, for the first code we wrote. Then the second print output is for the second code, which involved the integer number and the complex number. Now we can see this addition. Now the integer has been added to the complex, and I told us that the complex number is a number that contains a whole number part and an imaginary part. Okay, so now this is a whole number, which is the integer, and you looking at it very well, you see that the whole number part has been dealt with, since we don't have any imaginary part in this integer. So obviously 8 plus 5 is giving us 13, and then we have the 3j attached, which is the imaginary part. Okay, so this is also an implicit conversion, because automatically this has been converted. Okay, good. So you can also convert into strings. Okay, you can convert to string. Let me clean this. And when I say string, I want to believe you know the meaning of string by now. I told us that strings are seen as text in any write-up. Okay, strings are recognized as text in any write-up in Python program. Now I can actually say y is equals to 5. Let me put this 5 in quotes. 5. Okay, y is equals to 5. Now the 5 you're seeing here is not an integer, it's not a number, because it's in quotes. So we call this a string. Okay, the 5 you see here is not a number, it's a string. It's a string because of the quotes, so it is recognized as text. Okay, so if I want to know the type of this, I can just say find. If I want to verify to know if this is actually a number or a string, I can just say find. Then I'll check the type y. Okay, let me figure out what type of data we're dealing with. So I will just say type y, because y is a variable store for string 5. Okay, now type y, let me just go ahead and print find and see what happens. Print find. Okay, so it's going to give me a class string. Yes, so class string, and it simply tells you that this is not an integer. It's telling you that this is a string, it's recognized as a text. Now let me remove the quotes and then check the type again. Now I've taken off the quotes. I will still run my code again and see what happened. Now you can see the conversion, it is back to class integer. Yeah, so this tells you that anything enclosed in a quote is a string. So this is one basic way of actually finding out if what we're dealing with is a string or is another form of data type, okay, apart from string. So we can actually do a conversion. We can do a conversion. Now if I want to convert my my integer here to a string, I can simply, a very simple way is by saying, I can just say, okay, I can say inv, I can use anything, inv is equals to, since I want to convert to a string, I will say str. It's a very short form of string, str, then I'll have my y inside. Okay, I'll have my y inside. I will explain bit by bit what is happening there. Then I'll print my inv. I'll print my inv. Let's see what happened. Okay, string y. Okay, so what is happening here is that I was trying to convert this. Okay, y is equals to 5, inv equals to string y. Okay, so let me see the type of inv. I can just say, okay, find equals to type in bracket inv. Okay, print, I'm going to print find. Let me print my find. Print find. Okay, print find. All right, now printing find, you can see that the class is string. Okay, the class is string. It's telling you that that has been converted to string. So with the keyword type, it is the type keyword we use to know the the nature or the type of the data we're dealing with. Okay, initially 5 was actually an integer in this case, but with this conversion, we are made to understand that now it is now what? A string. Why? Because we introduce an str. Str simply means string, and I say str means I'm converting y to a string. So if you want to convert anything, you can introduce the keyword for that particular conversion factor. There's always a conversion factor, like if you want to convert this to a string, you just introduce the str. If you want to convert this to a float, you can just turn the, instead of str, you can just write float at the back of the y, then print inv. Okay, so if you print inv, let's see what happens. Good. So you can see that the value has been converted to a float 5.0, and I told us that floating point numbers are decimal numbers. Okay, decimal number. Initially it was just a single 5, but with this conversion we have 0.0 added to that number, and also that also takes effect over here, and we can now see that the class that was formerly string has been converted to floats. So these are just the very simple ways you can do some conversion. We call it Python type conversion. You can actually convert from one data type to another data type depending on what you are doing at that particular time. So most times you are required to do a conversion. If you don't do the conversion, you want to run your code, you notice that your code might not run in that particular instance, simply because it requires you to do a conversion. For instance, maybe you may want to take input from your users, and the input you're expecting from your users, maybe you have actually a kind of written an input statement, and you're expecting an input from your users, and you want that input to be a float point. Maybe you want them to supply a floating point number, or you want them to supply an integer, or you want them to supply a string. Okay, after writing the code, most times it will be necessary for you to specify by introducing those conversion factors. If you want it to be a floating point, you can introduce a float before the input. Don't worry, we are going to come to that. Okay, if you want it to be an integer, you can just put an int. Integer is we just use the int keyword, int keyword. Okay, so if you want it to be if you want it to be an integer, you just use your int. Okay, so if you want it to be a floating point number like we did here, you can just have your float there. But if you want it to be a string, you have your str. So these are the conversion keywords in use in Python for you to be able to convert from any data type to another data type. And apart from these ones we are looking at as well, you can also convert your lists. Okay, we're not just dealing um, with integers, floats, complex numbers. You can also convert your lists. You can convert from tuple to list. You can convert from list to tuple. For instance, you have a list here. If you have a list of this sort, and we know very well that our list is actually a collection of items enclosed in a square bracket. So you can have a list 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now I want to convert this. I can simply say okay. I can say okay. I can call it whatever I want to call it. I can just say okay, convert conv. Okay, convert equals to. Now I want to convert this to a tuple. Okay, if I want to convert this to a tuple, I'll simply just type in convert tuple. Okay, tuple. Then in parentheses I'm going to write my list. Okay, my list will be inside that parenthesis. Now in this case, the tuple you're seeing here becomes the conversion keyword, and this simply means we want to convert this list to a tuple data type, and that's what we are simply saying here. We want to convert our list here to a tuple data type, and the very simple way to do that is by just writing this tuple here. So I think this should be like the fourth, or even I think more than four, let me say the fourth keyword I'm bringing in this lesson. And in this case we are converting a list, and I'm having this. So now I'm going to check the type. Okay, I'm going to check the type to know if this is still a list or a tuple. To do that, I'm going to say, I can just say check equals to, then I'll say type. In parentheses I'll have my conv. Okay, so check equals to type conv in parentheses. So I'm going to go ahead and print my check and see if it's giving me a list. That means it was not converted. But if it's giving me a tuple object, that means the conversion was successful. So I'll just go ahead and print my check. I'll print my check. Print check. Okay, so let me run this. Good. So now you can see that over here we're having a class, and the class is tuple. But where did we start from? We started from the list. Okay, we started from the list, and this was a list, but eventually we've been able to convert this list to a tuple object. Okay, to a tuple object. So now we just checked, and it's telling us that this class is now what? Is now tuple. Okay, so these are the few conversions you can do, and we need to practice this. I want to believe by now, you're following. I want to believe the class is following all we have been doing. Okay, and all these processes we're going through, like what we have here, is a very clear example of an assignment statement. I think I've talked about that before. The first line you're seeing here is an assignment statement, and I say assignment statement is a statement that contains, you have the variable, and then you have the item assigned to the variable. And I say the variable is actually a store of value that contains the item. Okay, so the item could either be an integer, it could be a string, it can be a float, it can be a complex number, it can be a list, it can be a tuple, it can be a set, it can be a dictionary. Okay, so we have all these, and we have variables containing them. In this first line, you're seeing line 4. Line 4 there is a variable list. Okay, and inside the variable list we have this list running from 2 to 9. And the second line, that's line 5, we have there. We also have an assignment statement. We have a variable here, and we have a conversion factor, tuple, and we are converting this list. Okay, we are converting this list to a tuple. to a tuple. Okay, now after doing that, I actually checked the type, and eventually I got the output class tuple, which tells me that the conversion was successful. Please, before we go on in the lesson, I've just been notified that our lesson will end in 10 minutes. So after the 10 minutes, I'm going to open up another. I'm going to send another code to the WhatsApp platform. Please, I will send another code immediately. Then you will join again for the class, please. So I was just told now that in the next 10 minutes, the lesson will. That's the message I'm getting from Zoom. So in the next 10 minutes, I cannot extend the time, so it will end, then I'll start again. I will just continue from where I stopped. Yes, thank you very much. Okay, so now that's just it for a Python type conversions. And in looking at the Python type conversion, we have looked at the conversion from integer to float. Okay, from integer to float. We have looked at also the conversion from integer to complex. Okay, complex number by doing addition. That was an implicit conversion. It means automatic conversion, because in our illustration we're able to add an integer number with, we added that, we were able to sum it up with a complex number, and we got a final output. Okay, and I explained the meaning of a complex number, and I said a complex number is a number that has a whole number part and also an imaginary number parts. Okay, I give a clear example of the complex number. And also we have the conversion from between the integer. We can convert from integer to strings. We can also convert from string to integer. And also we have also looked at conversion from a list to tuple. We can also convert from tuple to a list. Okay, like what we have here now, we just converted from a list to a tuple. If I want to convert from a tuple to a list, I'll just change this to a tuple. Okay, if I change this from a square bracket to a parenthesis, so this automatically becomes a tuple. This is what a tuple is. In this case, if I want to convert this to a list, I will just change this to a list. I'll just write list out here. Then I may just change this keyword to tuple. I may just say TUP as my keyword, and I will do the same thing here, TUP. So this is telling us that we can do the conversion both ways. Okay, so check, everything remains the same. So in the first instance, we actually converted from a list to a tuple. Now we're converting from a tuple to a list, and you can see the class attributes here that is telling us that yes, this tuple has been converted to a list. So it can go both ways. It all depends on what you want to do in the course of your programming, but it can go both ways. So I want to believe you are actually getting this. So from here, I want to look at the topic this evening. Maybe by the end of the class, we'll just entertain some questions. So I want to look at a few topics on iteration. Okay, iteration control statements. I want to look at topics on iteration, and looking at iteration, and I know I've explained that iteration simply means looping through, looping. And when I mean looping, it means maybe you want to write a code that will have to repeat itself over and over again, or you want to write a code that will have to go through a process. Okay, go through a process repeatedly. That is what we call iteration. Okay, now there are so many methods of iteration. We basically call the methods loop. Okay, the loop, and we have the while loop, and then we have the for loop. Okay, we have the while loop and the for loop, and we're going to look at this briefly. Let's know how this works. Okay, let's see how it works. So like I said, we're going to look at iteration in the Python program. So okay, we're going to look at the for loop. Sorry, let me look at the while loop first. While loop. Okay, so we're going to look at the while loop. That will be the first thing we're going to look at. And a while loop is actually an iteration in writing a while loop, we're writing an iteration statement. Okay, we're writing an iteration statement in writing a while loop. But there are three basic, parts of a while loop. The three basic parts, and those parts are: number one, we have the initiation parts. We have the initiation parts. Okay, then we have the condition parts. Then also we have the updation parts. We have the updation parts. Okay, so you need to know about this, because every single thing, everything, most of the methods we'll be considering are guided by principles, and if you understand the principles very well, I think it will go a long way to help you. So if you want to write a while loop, you should have this in mind. The first thing you do is the initiation part. And for instance, if I want to write a very simple while loop, I can just start by writing the initiation. I can just say my n is equals to 5 or 6. Okay, this is an initiation part. N is equals to 6 is my initiation part. Once I'm done with this, I'll go ahead with the next, which is the condition. Condition I'm going to give in this. Okay, so I can just say I can just say while, since I'm dealing with the while, while n, okay, while n is less than 6. Now this is the condition. While n is less than 6 is the condition. I can say print n. I can say print n. Okay, so the print n now is the updation part. Okay, while n is equals to 6, sorry, while n is actually equals to 0, then while n is less than 6, print n. And it simply tells me that I've initiated this and n is equals to 6, and I said as long as n, okay, remains, while n is less than 6, print n. So I'll just go ahead and run this. Okay, print n. So it's giving me, like I said, when you have a exit code 0, there is nothing wrong with your code, but the only thing is that maybe the conditions you're looking at are not okay. Okay, now what could be the problem with the condition? I said while n is less than 6, but n is not less than 6, n is 6. That is why, like I said, the code is okay, but there is no output because of the condition. But if you want to have an output, definitely you can just decide to reduce the value of n to 5. Then you go ahead to run the code again. Now you have n being printed out, okay, continuously. You're having this value running continuously, and this is what we call an infinite loop. An infinite loop. Okay, good. So this is the while loop. So the while loop, like we said, let me just go ahead and stop this. I'll just stop this. So the while loop, like I said, contains three parts. We have basically, you have the initiation part, you have the condition part, you have the updation part. Okay, you have the updation part. So it doesn't mean that you can decide to introduce other things in between. Okay, in the course of the code, depending on the nature of the code you're writing, you can decide to introduce any other line of code before the final print statement. Okay, so that is just the basic thing about it. So, and that's just it about the while loop. You have these basic principles and the basic part of the while loop. And the other iteration we're going to be looking at is the for loop. Okay, the for loop. And the for loop makes reference, we use the for loop to actually iterate over a list. Maybe you want to print out all the items in a list, you can use a for loop. Now for instance, you have a list, you can say name equals to, in the list you have Daniel.